Properties and behaviors of gases are the science behind many common household items and activities. This video will demonstrate and explain a couple of different gas laws that will help to explain some of the things we see in our day-to-day lives. Charles' law states that the volume of a sample of gas is directly proportional to its Kelvin temperature if the pressure is kept constant. V equals the volume, T equals the temperature, and K is constant that depends on the number of moles and the temperature of the gas. Because K is a constant, we can say that the first set of conditions is equal to the second set of conditions. So the volume of the first sample divided by the temperature of the first sample will be equal to the volume of the second sample divided by the temperature of that second sample. So this means when the temperature of a gas at a constant pressure is increased, the volume will also increase. And if the temperature decreases, the volume will also decrease. Boyle's law, on the other hand, states that the volume of a sample of gas is inversely proportional to its atmospheric pressure if the temperature is kept constant. V equals the volume, P is the pressure in atmospheres, and K is a constant that depends on the number of moles and the pressure of the gas. Therefore, since K is a constant value, we can say that the first set of conditions is equal to the set of conditions. So what this means is that when the pressure of a gas at a constant temperature increases, the volume will decrease. This experiment had 3 parts. For the first part, I found a soy sauce packet that could barely float in a bowl of water, as you can see here. I placed the soy sauce packet into a clear plastic bottle and filled it with water, then screwed the cap on tightly and squeezed the sides of the bottle to see what would happen. I then repeated this process with a pen cap that had clay putty covering the hole. For the second part of this experiment, I found this candle and placed it into this plastic dish using some of the clay. I put some water into the dish and then I took a clear glass and inverted it over the lit candle to see what would happen. In the third part of this experiment, I obtained a package of pop rocks and I observed the result of placing the pop rocks on the tongue. My hypothesis for the first part of this experiment was that when the bottle was squeezed, the soy sauce packet would move downward away from the surface of the water. I assumed this would happen because of Boyle's law, which states that when the pressure increases on a certain volume of gas, the volume will decrease. And so I assumed that the soy sauce packet would be less buoyant as the volume of the gas inside of it decreased. This is my hypothesis for part 2 of the experiment. I assumed that when the glass was placed over the lit candle, the temperature of the gas would increase inside of the glass, which would cause the volume to increase as well due to Charles' law, which states that temperature and volume are directly proportional on a certain amount of gas. And so I knew that the gas would expand and that the water level would go down inside of the glass. My hypothesis for the third part of the experiment was that when the pop rocks were placed on the tongue, the gas inside of them would increase, causing the gas to escape from the candy and cause that popping noise or sensation that we hear when we eat pop rocks. So for this first part, as I squeeze the water bottle with the soy sauce packet inside of it, the packet travels to the bottom of the bottle, and then as I release, the packet travels back to the top. So as I'm squeezing and the pressure inside is increasing, the packet is moving towards the bottom, and then as I release and the pressure decreases, the packet will travel back to the top. Okay, now we're going to try the same thing using a clear plastic bottle and this pen cap. So you can see again, as I squeeze the bottle, it will move to the bottom. And then as I release, it moves back up to the top. So we're going to do them side by side. So I have the soy sauce packet in this one and the pen cap in this one. When I squeeze them both, obviously, the bottle with the pen cap, I need to apply a lot more pressure as I'm squeezing the bottle to get the pen cap to move. Part 1 was a great example of Boyle's law. Boyle's law states that at a constant temperature, the volume of a gas is inversely proportional to the pressure of the gas. So when I squeezed the water bottle with the soy sauce packet, I increased the pressure on the gas inside of the packet. As the pressure on the gas increased, the volume of the gas decreased. This caused the soy sauce packet to lose buoyancy and it traveled to the bottom of the bottle. The same thing happened with the pen cap. Okay, so I've emptied my glass of water into the dish. I'm going to light my candle. And then I'll place the glass over the candle. And as you can see, as the temperature increases inside, the water level decreases inside of the glass until eventually the candle will go out. This was a great example of Charles' law, which states that at a constant pressure, the temperature of a gas is directly proportional to its volume. So when I put the glass over the candle, the temperature of the gas inside of the glass increased, causing the volume of that gas to increase as well. So when this happened, the gas caused the water level to lower to make room for the increased volume of gas inside of the glass. When the flame went out and the temperature decreased again, the water level rose due to a decrease in the volume of the gas. So we've obtained a packet of Pop Rocks here, and as you can see, when the candy is placed on the tongue, it immediately starts releasing carbon dioxide gas, which causes the quote-unquote popping sound. And then when the tongue is retracted back into the mouth, more carbon dioxide gas is released. This was another example of Charles' law. According to this package, the candy is processed with carbon dioxide. So they compress the carbon dioxide gas into the candy, and then when it's placed on your tongue, the temperature of the gas rises. This rise in temperature causes the volume of the gas to increase. It's then released from the candy, causing the popping noise and the sensation. Another example of a product that exemplifies gas laws is a soda can. Soda is created with carbon dioxide gas, which is what we know as carbonation. It's pressured when it's packaged, so the volume of carbon dioxide decreases, and when the top is opened, the carbon dioxide increases and escapes the can as carbonation. When you shake the can before you open it, the gas is distributed throughout the product, and then when you open the can, the pressure decreases and the gas expands and tries to escape, and that's what causes the fizzing that overflows the can. Understanding the relationship between the volume, temperature, and the pressure of a gas can really help us to gain a better understanding of how gases react in the environment around us. So now that we have a great understanding of Charles' law and Boyle's law, we understand better the relationship between all three of these properties, and we can make better assumptions of why gases behave the way that they do. Thank you for watching.